We're going to talk about oxidation numbers. This is something that's in section 2 of chapter 7 of your book. We did not go over it before the quiz. It would typically be on the quiz, but as you saw, it was not on the quiz, and it will be on a test on Tuesday, so it's definitely something to get to know. And I'm going to show you a few examples, and then you should be practicing to see that you can do it on your own. So let's talk about them. These are all going to come in at once, so it's going to be a little bit more than normal. So I'm going to let you fill all these words in. I'll just show them to you. It's using covalent bonds. It's assuming in an ion or molecular compound that there's a complete transfer of electrons. It's used to describe the distribution of electrons in the bonds. They don't have a real physical meaning, unlike the charges of an ion. And I know that you can read these, but I'm going to go through this in this amount of time, so I know about how much time you need. And it's officially written with the positive or negative first, and the example would be a -2, whereas a charge on an ion officially should be a 2- if that was its charge. So what do we mean by this? First of all, this is a, we know in a molecule for water, for instance, that there is not a complete transfer of electrons, that they're just shared between hydrogens and oxygens. What we're showing here is a number called oxidation number, which will show how much where the electrons are. It's assigning a number to show where the electrons are, not just a partial negative, partial positive, but an actual number to how much the electrons are in bonds. So here's some rules for how we're going to figure this out. The oxidation number of any uncombined element is 0. So let's say that we have, for example, that one that's on your sheet, number 9, is silver. Silver, and typically we do oxidation numbers by drawing a tie line like this. The oxidation number would be 0. If it was O2, which is also by itself oxygen, it'd be 0. So that's just an example. If it's a monatomic ion like number 10 on your sheet here, that has a +1 charge, I know it's just a plus on your sheet, but that would also be its oxidation number. So any other metal that you know the charge of, for instance, if it's iron with a 2+, that's also its oxidation number, would be +2 officially. So monatomic ion is just a charge on that ion. Here's some other rules to fill in. I know they're slightly out of order. This is actually number 3. But oxidation number of hydrogens +1, fluorines -1, just like the charges they would be if they're ions. Oxygen, it says, is almost always -2. In reality, it is always for our purposes. There are some weird exceptions, but even AP has gotten rid of those exceptions, so we're not going to worry about those. So we're going to talk about some examples of how we could use that before we get to this last one. So if we look at number 1, for instance, we have HF. HF, hydrogen is going to be +1 like it says. Fluorine is going to be -1 like it says. They're going to add up to 0 when they're in a compound together. If we look at water, H2O, oxygen is -2 like it says. Hydrogen is +1 for each atom like it says, so there's a +2 and a -2. Again, this does not mean that oxygen has a -2 charge inside of water. It just shows where the electrons are compared to hydrogen. The electrons around oxygen more. That's why it's a more negative value than the hydrogen is. Another good example is the H2CO3. H2CO3. This is number 6 on your sheet. Each oxygen is -2. Each hydrogen is +1. That's each of them. So if I look at their totals, the hydrogens together have a +2. The oxygens together have a -6. So to make everything equal 0, the carbon must be a +4. So as far as the oxidation numbers, we'd say hydrogen's a +1, oxygen's -2, carbon's a +4. It all has to equal 0. Again, in this case, what does that mean for carbonic acid? It means if I could watch the electrons, I would see that they're around the oxygen the most and around the carbon the least, because it's the most positive number. Now if we look at that last rule on this sheet, which is actually number 3 on your sheet, what if those hydrogen, fluorine, and oxygen are not involved? Because if they are involved, you can figure out the other one. For instance, carbon monoxide. Carbon's -2, it all equals 0, so carbon must be a +2. If they're not involved, like number 2 there, where it's Ci4, you would look at the electronegativities. The one that's more electronegative would get its charge it would if it were an ion. In this case, iodine is more electronegative, so it gets the -1 charge it would if it were an ion. Since there's 4 of them, there's a 4 minus 4 from all the iodines, the carbon's going to get a plus 4 oxidation number. Again, it just means that the electrons are around the iodine more than the carbon, and it's assigning a number to how much more it is around that iodine. Very important as we talk about, get in AP chemistry and talk about reactions and where electrons are going during a reaction. If we look at the other rules, we've kind of addressed this a little bit already, but monatomic ions like potassium +1 or calcium +2, those would be their oxidation numbers also. When you're in a compound, they all add up to 0, which we've already been practicing. The one thing that you haven't seen yet is, what if it's an ion? If you look at number 8, SO4 is a -2 charge. So instead of all those adding up to 0, they're going to add up to -2. So oxygen's -2 for each. That's its oxidation number, but there's 4 of them, so that's a -8 for all the oxygens. So that means that the sulfur must be a +6, so everything can equal -2. Because all the oxygen supply are -8, +6 for the sulfur. Again, it doesn't mean the charge they're forming, it just shows that the electrons are around the oxygen much more. And then we can follow those electrons as it goes through chemical reactions to see which atoms are losing and which atoms are gaining electrons. So I can see on the front there's many more that we didn't go over together. On the back there's many, many more. Again, I'm not going to check this. I'm not going to grade it. I'm not going to collect it. The answers are on Schoology. They're on the hood. The more you practice, the more you'll know, the more confident you'll be, and these will be on the test next Tuesday. Maybe not a lot, but there's definitely going to be some. If you have any questions with them, be sure you let me know and check your answers.